All right, welcome to the last page of the practice common assessment. On question number 50, it says, what is the rate of change? Record your answer and fill in the bubbles on your answer sheet. Well, of course, you don't have one, but you know what I mean. Rate of change, that means that we're looking for the change in y over the change in x. So when I go from 1 to 3, so 1 to 3, I'm adding 2. When I go from 3 to 5, I'm adding 2. 5 to 7, I'm adding it 2. So my change in x is going to be 2. Make sure that you put it in the order of change in y over the change in x. And make sure you pay attention to which values are which when you're talking about the change. When I go from 4 to 8, I'm adding 4. When I go from 8 to 12, I'm adding 4 again. 12 to 16, I'm adding 4. So my change in y is going to be 4. And 4 divided by 2 will give us 2. So my slope, my rate of change, my m is going to be equal to 2. All right. Number 51, how will the graph of how will the graph of y is equal to 5x squared be affected by the coefficient of x squared becomes negative 5? Remember, when that a value or that number in front, when you get a negative, it doesn't change the width or the narrow. Now, this is a squared, so our graph is going to be, it's a happy first. So when we talk about looking at it on a graph, let me draw the graph. Okay, so when we draw our graph where it looks like on the graph first, when we talk about, we're talking about it being here on the graph, okay? So that is the y is equal to 5x squared. Now, when we reflect it, it's now going to be this way. Now sorry, that should be more clear. Let me fix that so that it's not quite so terribly crooked. So now we've reflected it. Well, which cross-axis this is? This is our x-axis. So it's going to be reflected across the x-axis. And that is our answer for number 51. Number 52, the line represents the equation of negative x plus 2 is graphed below. Which of the following best describes the change in a graph if the line becomes negative, y is equal to negative 1/2 x plus 2? So we did not change the sign. That still is negative. But the a value, so we went from 1 to 1/2, okay? So when we go from 1 to 1/2, so let's talk about this point here, because that's all of our questions here ask about the intercept, okay? And let's look at what happens. So our intercept is the point 0, 2, okay? And that's our y-intercept, okay? So let's see if anything happens with our y-intercept. So I'm going to plug that into our equation. So that's going to be 2 is equal to, when x is equal to 0, y it's going to be equal to 2. So that's not going to do any changes. Okay? Now, let's see if we put it in, talk about our x-intercept. Our x-intercept here is going to be 2, 0. So now let's put in 2 for our point. So that's going to be y is equal to, we're going to put negative 1/2 times 2 plus 2. All right, so then that's going to give us, this is going to become negative 1 plus 2. So then that's going to give us y is equal to, all right, so then that's going to be, y is going to be equal to 2. Oh, sorry, not 2. That's going to give us 1. So that new coordinate point, when we're going to go from 2, 0 to 2, 1. So what happened? So if we're talking about going from 2, 0, it's now going to get moved to here. Okay, so it's going to get shifted up. Okay. So it's our And then let's look at the y-intercept again. I did the y-intercept a little bit wonky. So if we're talking about our y-intercept, which is going to be 0, 2. So that means that our y-intercept, if I plug 0 in for x for here, if I plug in 0 for our equation, y is still going to equal 2. So that means that our graph is going to look like this. So if our slope is going to change now, so now it's going to look like this when we graph it. Okay? Because our y-intercept is still going to be at 2. So our graph became more, what happened to those values? Did the y value got bigger? So, and then we're not really talking about the x-intercept did not change. Okay? And the y-intercept now, let's think about where the y-intercept is going to be at if everything ends up moving. Okay, so let's graph this. So we have our graph here is at intercept is that, so we're going down 1, and then we're going right 2, going down 1, right 2. So now our y-intercept, our x-intercept, not our y-intercept, my apologies. So we went from our x-intercept at 2, 0 to 4, 0 now. So our y-intercept increased, the x values increased, so our answer would be F. Number 53, which statement best describes the function below? This is a horizontal line. Remember, hoivux. Hoivux. Horizontal, 0 slope. Y equals some number for an equation, or we can say y-axis. Vertical line. Oops. I don't know why it's not showing. It's not writing on my board. Okay, vertical, hoivux. I'll write that here, hoivux. So we can say horizontal, and we can say 0 slope, and y equals some number, vertical line, undefined, and y equals some number. Okay, so then that means that A is going to cancel out because that's y equals. Because this is a vertical line, so that means it's going to be x equals. And that intercept is going to be at... No, sorry. What am I doing? This is a horizontal line. So that's going to be a y equals. So that's not that one. It's going to cancel out C and D. So our answer choice is going to be either A or B. But according to our rules here, horizontal lines have a defined slope, and that defined slope is a slope of 0. So our answer choice is B. Number 54, the last question, we're going to use I'm going to do that on another video to show it on my phone so that I can show you the calculator, because we're going to be doing a stat plot for that one. See you then.